Hello everyone, welcome back. Today we'll be going over 10.5, rationalizing denominators of radical expressions. So, for starters, an example of what we mean by rationalizing a denominator. We'll start with an example involving just numbers. We'll get to variables in a minute. So 7 divided by square root of 2. 7 is a nice, neat, pretty integer. It's a natural number. It is also a rational number since it can be written as 7 over 1. Square root of 2, however, is an irrational number. The decimal representation would go on forever. If you punch it into your calculator, it'll round it out just as far as your calculator can go, but it does go on forever like the number pi. So the idea is, if we want rational numbers only in the denominator, we let the radical sort of do the talking, so to speak. So this one has an implied index of 2. It's a square root. So to make that into a perfect square, I'll multiply by another square root of 2. And so that I'm not changing the value, we'll multiply the top by square root of 2 as well. That way I'm multiplying by something worth 1. I'm changing the look, but not the value. So at the top we have 7 root 2. At the bottom, square root of 2 times square root of 2 is just 2. Since 2 squared is 4, square root of 4 is just a 2. So notice we didn't get rid of the radical entirely, we just moved it to the numerator, and that is what would happen with these. So our next denominator that we're looking to rationalize, we'll do, well, let's say 2 root 9 over root 16y. So this one, just a little bit of legwork at the start of it to do some simplifying. So square root of 9 is 3, and in the denominator, we can do a little simplifying. 16 is a perfect square, y is not. So we have 2 times 3 over 4 square root of y. 2/4 is a half, so we have 3 over 2 square root of y. Okay, it looks a little bit better. No perfect squares under radicals anymore. But the idea is, again, we're rationalizing the denominator, and I still have a radical in the denominator. This one, like the last one, was a square root. So I'm looking to get a square underneath. So I'll multiply top and bottom by square root of y. So we have 3 square root of y over 2 square root of y squared, which becomes 3 root y over 2y. Again, in section 10.1, the author does stand by having absolute value marks there. After section 10.1, they're not necessary. Just as a heads up here, I can't do any canceling. 1 is underneath the radical, 1 is not. So they are not common factors. This is as far as we can take that problem. Next up, we'll take a look at what happens with a cube root example. So we'll do a cube root of, well, let's go with 2/25. So first things first, let's split up that fraction. Turn it into cube root of 2 over cube root of, instead of 25, I'll go with the easier to work with exponent version of 5 squared. So the index says I need 3 to get out. The exponent says I've already got 2 of them. I need 1 more 5 to get out of there. So I'll multiply the bottom by cube root of 5. Again, so that I'm changing the look but not the value, I'll multiply the top by cube root of 5 as well. So then at the top we have the cube root of 10. At the bottom we have cube root of 5 cubed. Cube and cube root will cancel one another. So this is the cube root of 10 all over 5. So notice I'm drawing my fraction bar long enough that I can tell that the 5 is not underneath this radical. Okay, so next up, we'll take a look at a fourth root example. So same instructions, rationalize the denominator. We'll do fourth root of x cubed divided by the fourth root of 32y squared. So when we have monomials underneath the radicals and we're rationalizing, it's easier to go to exponent form. So I'll hang on to the fourth root of x cubed, but instead of writing 32, 32 is 2 to the 5th power. If you need to draw your factor tree to break that down, go ahead and do so. You can finish that on your own, and we'll hang on to our y squared. This time our index again is the 4, so I need 4 or a multiple of 4 to get out from under here. Looking at the 2's, I have 5 to start with, so 3 more would bring me up to having 8 of those, which is a multiple of 4, so I could get out from underneath that radical. The y squared, I have 2, I need 4 or a multiple of 4, 2 more will do it. Again, I'm looking to change the look but not the value, so we'll multiply top and bottom by that same fourth root. So something worth 1. So now up top we have the fourth root of 2 cubed is 8, so 8x cubed y squared. And at the bottom we have the fourth root of 2 to the 8th y to the 4th. So we have the fourth root of 8x cubed y squared over 2 squared, or 4, and fourth root of y to the 4th is just y. So again, with the monomials inside the radical, write them as exponents if possible, and just count up how many more you need. And that's the version of 1 you'll multiply by. All right, so next up, we take a look at what happens if there are 2 terms in the denominator and we want to rationalize. So for this one, we're going to do a quick warm-up problem. So I'd like you to try out a quick multiplication problem. So we'll do 2 root 7 minus root 11 by 2 root 7 plus root 11. So go ahead and pause the video and we'll be back in a minute. Okay, welcome back. So 2 terms times 2 terms, that means we are going to be foiling this out. So first times the first, 2 by 2 is 4, square root of 7 times square root of 7 is 7. Outside times outside, positive by positive is positive. And we have 2 square root of 77, so root 7 by root 11. Inside times inside, negative by a positive is a negative. 2 is outside, inside root 11 by root 7 is root 77. And last times last, negative by a positive is a negative. Square root of 11 times square root of 11 is square root of 11 squared. And then we just have a little cleanup. So 28 plus 2 root 77 minus 2 root 77 is worth 0. Those will cancel out. Square root of 11 squared is just 11. So 28 minus 11 is 17. So notice that our product no longer had any radicals in it, and that is the general strategy, that as long as we're multiplying the same 2 terms with opposite signs in the middle, we get that nice neat cancellation in the middle of the radical terms, And we get the nice, neat, pretty, perfect squares on the ends that get rid of our square roots. So that is the strategy that we'll use. These two are what are referred to as conjugates. Conjugates of one another. So that's the only tool really that we need then to handle rationalizing denominators that have more than one term. So we'll start with 3 over 2 root 5 plus 9. So first off, I can't touch the 3 and the 9. 3 is a factor of the top. 3 is not a factor of the bottom. 3 is a factor only of one term in the bottom. So if I'm looking to rationalize this thing in the denominator, that means I have to find the conjugate of 2 root 5 plus 9. Well, that would just be keeping the 2 root 5, keeping the 9, but flipping that plus over to a minus. And just like before, if I'm looking to have something that has the same value, I'm only allowed to multiply by things worth 1. So I have to multiply the top by the same thing. That way this part is worth 1. So at the top we have 3 by 2 root 5 minus 9. At the bottom, 2 by 2 is 4. And then square root of 5, square root of 5, square root of 5 squared. That's just going to come out to a 5 in a moment. Outside times outside. Positive by negative is a negative. 2 by 9, 18. Hang on to the root 5. I'm going to need a longer fraction bar here. So we did our first, our outside. Next up, our inside. Positive by positive is plus. 9 by 2, 18 again. And we still have our root 5. And there's that nice, neat, pretty cancellation we see. Same two terms, one with a minus, one with a plus. They're going to add to 0. And last times last, minus 81. So up top, 3 by 2 root 5 minus 9. Down on the bottom, 4 by 5 is 20. Middle two terms drop, minus 81. So 3 by 2 root 5 minus 9 all over unlike signs. So we'll subtract those absolute values, and the negative was further from 0. So I'll slap a negative on that. All right. 3 and 61 don't have any common factors, so that's as far as we'll go on that one. Now, occasionally we do have something happening both numerator and denominator. So we might have root 5 plus 3 over root 3 minus, we'll go root 5. So same goal. I want to rationalize the denominator. I want a denominator like the last one that has a nice, neat rational number, no more radicals. So since it's the denominator we want to rationalize, it is the denominator that we use the conjugate of. So hang on to the root 3, hang on to the root 5, but in between, this time the minus flips over to then a plus. If I multiply the bottom by that, I also multiply the top by that same thing. So now we're just foiling the top, foiling the bottom, and seeing what comes out of it. So root 5 by root 3 is root 15. Root 5 by root 5 is a 5. Square root of 5 squared, we get just a 5 out of it. We have plus 3 root 5. And finally, plus, my apologies. We'll get the same answer either way since addition is commutative, but I'll keep the usual FOIL order. So root 15 plus 5 plus 3 root 3 plus 3 root 5 all over square root of 3 times square root of 3 is 3. Then we have plus root 15 and minus root 15. Goodbye to the outer and inner again. And then negative by a positive is negative. Root 5 by root 5 is 5. So up at the top, I don't see any like terms. We'll just bring it as it is. So root 15 plus 5 plus 3 root 3 plus 3 root 5. And down at the bottom there, 3 minus 5 is a negative 2. You might see it written this way. You may see it written with a parenthesis around the numerator. And a positive 2 at the bottom. Or you may even see it distributed. Any of those three are just fine. So any of these last three are okay for a final answer. Now, of course, they do occasionally also let us play with variables, but the idea is still exactly the same. We want to use the conjugate if there's more than one term. So we'll do, well, let's say 4 plus root x over 2 minus root y. So my goal is a denominator with only rationals in it. Here I have a square root of y. So to get rid of that square root, since it's two terms, I need the conjugate. If it were just one term, we would be using the previous method where we just counted up how many we have versus how many we needed based on the index. So that minus in the middle now turns to a plus. Other than that, the terms look the same as they did in the denominator. So then we're just foiling again. So 4 by 2 is 8 plus 4 root y. Inside times inside plus 2 root x. Last times last. So plus square root of xy. Denominator 2 by 2 is 4. Outside times outside plus 2 root y. Inside times inside minus 2 root y. There's that cancellation we were hoping to see. And then finally minus square root of y squared. So numerator, really no more cleanup to do, so we'll bring it along as is. Try to make my y look more like a y than it did in the last step. Denominator, we have a 4. Outside and inside have canceled out. And my sign, square root of y squared, is just a y. And now we have no radicals left in that denominator. That's what they mean when they ask us to rationalize. Now there is one sort of unique situation you'll encounter in your math career where they ask us to rationalize a numerator. Typically it's the denominator they want rationalized, but there is one sort of special case. If they do want that, though, they will specify. So again, this one is just the special case. So we would have square root of x plus h minus square root of x all divided by h. So notice if they said rationalize the denominator on this one, we'd already be done. No square roots at the bottom. But this time they want us to rationalize the numerator. The numerator has two terms, so I need the conjugate method. So I'll keep the square root of x plus h. I'll flip the middle that was a minus over to a plus. I'll keep root x. And so that I'm multiplying by something worth 1, changing the look but not the value. We simply flip the sign and FOIL it out. So at the top, square root of x plus h by square root of x plus h is square root of x plus h quantity squared. So I got those parentheses, since it's not just the h being squared, but the whole thing of x plus h. Outside times outside. Positive by a positive is a plus. Square root of x by x plus h. Inside times inside. Negative by a positive is a negative. square root of x by x plus h again. And last times the last, negative by a positive is a negative, and root x times root x, square root of x squared. Denominator, since we just have a monomial, you can either distribute the h or keep it as is. If it were 2 terms by 2 terms, go ahead and just FOIL it out. So then up top, we have square root and a square. Those will cancel one another out, and we have an x plus h. Plus and minus the same thing. Those also will drop. And hang on to your minus. Square root of x squared is x. And we have the h by square root of x plus h plus square root of x. So on this one, you might notice one more bit of canceling that we can do. X minus x is 0. So we have h over h times root x plus h plus root x. Let me close that parenthesis there. So one more thing you might notice is h over h is worth a 1. So this one will turn into 1 over square root of x plus h plus square root of x. So again, this is just one application that you would use later in your math career where we would rationalize the numerator. Typically, though, you're going to be rationalizing denominators. Okay, so some problems to try out from section 10.5. Ran out of room at the bottom here. I'll just put it up here at the top. So 10.5, I would recommend 1 through 53 every other odd, as well as 83 to 87 odd. And that should do it. Okay, so stay safe out there, everyone. Hope to see everyone again soon.